Can misinterpreting stress-strain curves cause material failure? Imagine holding a piece of metal and wondering how much load it can take before it breaks. The secret lies in understanding what the stress-strain curve tells us. These curves are like maps of how materials respond when forces are applied. They show the relationship between stress, which is the force per unit area, and strain, which is how much the material stretches or compresses. At first, the curve is straight, meaning the material behaves elastically. This is the part where, if you remove the load, the material goes back to its original shape. The slope of this straight line is called the elastic modulus, which tells us how stiff the material is. But if you keep increasing the load, the material reaches a point called the yield strength. Beyond this, the material deforms plastically, meaning it will not return to its original shape even if the load is removed. Misreading the yield strength can be dangerous. If you think the material can handle more than it actually can, you might apply stresses that cause permanent deformation. Over time, this weakens the structure, and it might suddenly fail under a load that seemed safe. Also, confusing engineering stress with true stress can lead to errors. Engineering stress uses the original cross-sectional area, but as the material deforms, the actual area decreases. Ignoring this can cause underestimations of the material's capacity. Different materials behave differently on these curves. Ductile materials stretch a lot before breaking, giving clear warning signs. Brittle materials, however, fracture quickly after elastic deformation, often with little plastic deformation. Misinterpreting these behaviors can lead to choosing the wrong material for a specific purpose. For example, assuming a brittle material can bend like a ductile one might result in sudden, unexpected failure. Stress concentrations are another factor. These are areas where stress is higher, like sharp corners or tiny cracks. If you only look at the overall stress-strain curve without considering these local effects, you might miss the warning signs of failure. Residual stresses from manufacturing can also cause unexpected breakdowns if not accounted for. In real-world applications, understanding the entire stress-strain curve is vital. It helps predict how a material will behave under different loads, when it will yield, and when it might fracture. Misinterpreting this data can lead to mechanical failures in bridges, machinery, or even small components. By carefully analyzing these curves, engineers can design safer, more reliable products. So, if you misunderstand the stress-strain curve, you risk underestimating the true limits of your materials. This can cause unexpected failures, costly repairs, or even safety hazards. Proper interpretation of these curves reveals the real mechanical limits, helping us prevent breakdowns before they happen.